Hello. It's Ma'am Vici at your service. The discussion in this video is still on the basic concepts of fluid flow phenomena, specifically on how we can calculate the Reynolds number. For those who have not yet watched my previous video on the basic concepts of fluid flow phenomena, I would like you to first watch that video for a better understanding of what I will be discussing. Now, yes, we will discuss a Reynolds number problem. Before I continue, may I request you to hit the subscribe button. The problem states, water at 303 Kelvin is flowing at the rate of 10 gallons per minute in a pipe having an inside diameter of 2.067 inches. Calculate the Reynolds number using both English units and SI units. The situation in the problem is water flowing in a pipe, and the values given are 10 gallons per minute flow rate, 303 Kelvin temperature, and 2.067 inches pipe inside diameter. The problem requires us to solve the Reynolds number in English and SI units. A good practice when solving momentum transfer problem is to interpret it in the figure. As engineering students, we should be good, if not experts in this technique. Besides, this gives you a better understanding of the problem and not just be guessing what values to substitute in the equation. Observe how this is being done. When solving a problem, my advice to the students is to start with the equation of what is required to be solved in the problem. This approach will give you the direction, help you know the variables in the equations that are not given in the problem, and what variables needs to be calculated or whose values must be searched from tables and graphs based on the given problem. Hence, we start with the equation of the Reynolds number, since it is the value required by the problem. NRE equals diameter times velocity times density over the viscosity. Then define the variables or cite your sources. This is necessary in unifying the interpretation of the equation. Thus, as what I've already discussed, NRE is equal to the Reynolds number, D is inside diameter, V is velocity of the flowing liquid, density, that is your rho of the flowing liquid, and mu is the viscosity of the flowing liquid. The diameter is given in the problem but must be expressed in the English system of units to be consistent with the requirement of the problem. Thus, the diameter DI equals 2.067 inches times there is 12 inches in 1 foot, and we are getting 0.17225 feet. What else is given in the problem? Well, there is volume. We will also convert it to the English system of units. Thus, we have the volume equals 10 gallons per minute, and there are 7.481 gallons in 1 cubic feet, and there are 60 seconds in 1 minute, and we are getting therefore 0.022 cubic feet per second. Or maybe, I'm sure that it will still be easier if you just go to your calculator and let it do the conversion. Also, recall that volume is equivalent to velocity times area, so we can already calculate the velocity using the equation. Thus, velocity equals V over area, and that is the area is 1 over 4 d squared. And so we are getting a velocity of 0.957 feet per second. Let us go to the value of density given that the temperature is 303 Kelvin. And from the table of densities, the density of water at 302 is 995.948 kilograms per cubic meters, while at 304 the density is 995.346 kilograms per cubic meters. Notice that there is no value for 303 Kelvin. So use the values at 302 and 304 to interpolate. After interpolation, the value obtained is 995.647 kilograms per cubic meters, rounded off to 0.996 grams per cubic centimeters. Now I need to convert the units to the English system. So the value of the density of water becomes 62.18 pound mass per cubic foot. You can do this in your calculator. Then we go to the viscosity at 303 Kelvin. From the table of viscosities, the coordinates of water are x equals 10.2 and y equals 13. We then plot the coordinates on the graph. The viscosity is approximately 0.8001 centipoise, and I bet you have to practice reading on graphs to arrive at a very good estimated reading of the value. Then substitute on the equation of the Reynolds number the values of the diameter, which is 0.17225 feet, velocity 0.957 feet per second, the density, which is 62.18 pound mass per cubic feet, the viscosity, which is 0.538 pound mass per feet second. NRE is calculated to be 1.905 times 10 to the fourth. This value is greater than 4,000, so the flow of the fluid is turbulent. We will now go to the next requirement of the problem, solving NRE in the SI units. We start with converting the diameter to meters, that the diameter is equivalent to 0.525 meters. Then, if you recall, we were given the volume V equals to 10 gallons per minute. This value leads us to the calculation of the velocity. But first, we will convert the volume into the MKS system of units, and that will make it consistent with the converted unit of the diameter. The calculation gives us a volumetric flow rate of 0.0063 cubic meters per second. So, for velocity, we rearrange the equation of the volume. And so we have now the volume equals V times area, and velocity is therefore volume over area. And knowing that the cross-sectional area of the pipe also is pi over 4 d squared, we get a velocity of 0.291 meters per second. Recall also that the density we obtain from the tables of densities of pure liquids is 995.647 kilograms per cubic meters. This value does not need conversion, so we go to the viscosity mu, which is 0.8001 centipoise. Hence, we have 0.8001 centipoise, and for every 1 centipoise, you have 0.001 kilograms per meter second. And so we are getting a value of 8.001 times 10 to the minus 4 kilograms per meter second. We will now substitute the values of the diameter, velocity, density, and viscosity on the equation of the Reynolds number. The calculated value for NRE is, surprise, it's still 1.905 times 10 to the fourth. Of course, it's the same value when we solve the Reynolds number in the English units. And if you are not able to get the same value, then review your solution because you must have been doing it wrong. The Reynolds number is dimensionless. So if you follow the principle of consistency of units, whether using the English units or SI units, it will always give you the same number or the same answer. Finally, let me give you something to do after watching this video. This problem will not require you to go to a table or graph of chemical data or constants. All you must do is know the equation and substitute. And voila, you get the answer. And try doing this directly on your calculator. This is a good preparation for your examination when time is of the essence. And now, thank you is in the order. Thank you for the music, the songs I'm singing. Thanks for all the joy they're bringing. Please watch out for my next video. I will be discussing to you how to do dimensional analysis.